Hi guys. So I guess I'll be doing the entire study guide video because we had tutorials and I had kids that did not remember how to do sign diagrams. Um, One thing about the test, make sure you know how to do um, the entire study guide. Okay, I know there were different kinds of problems on your homework, but I'm going to focus on the problems that I put on the study guide, the kind of questioning. Okay, so let's get started. So, um, using sign diagrams to solve. Okay, let's go ahead. Using sign diagrams to solve for x. And remember, when you solve for x, you're looking for a range of values. Okay, we're not just going to put the sign diagram on there and then say, hey, that's the right answer. Okay, so if you have, I'm going to move this 4 to the other side, and I could rewrite this as 5x squared plus 8x minus 4 is going to be greater than 0. Okay, let's go ahead and factor. And I just use a trial and error method. And then we have I'm going to use 2 and a 2, and that's going to be a plus and a minus. So positive 10 and a minus 2 is going to give you this, right? This is a positive 10 and a minus 2. That's going to give you a positive 10. I mean, positive 8. I'm sorry. I'm a bit tired. Okay. Now, let's go ahead and solve for the critical point. So x is 2/5 and x equals -2. And then let's go ahead and make our sign diagram. We have a -2 and a 2/5. Okay, and I'm going to take a look at some, what can you do if you can't, if you're stuck making videos for you guys, then the least you could do is use different colors, right? Okay, so let's go ahead and put a -3 in. That is going to give me a positive, believe that's going to give me a positive, right? And I could put it into the factored form. It's going to be a -15. It's a negative and a negative. That's going to give me, or you can put it into the beginning trinomial. So we have a positive, and then I'm going to put a 0 in. That's going to give me a negative, and I'm going to put a 1 in, and that's going to give me a positive. And I'm just thinking in my head, hey, I have 1 squared, and that's going to give me a positive. And then 8 times a 1, that's going to give me a positive. And then it's going to be, those are going to be large enough numbers. When you subtract it by 4, it's still going to be a positive. Okay, notice that it is greater than 0. It's greater than 0. So it doesn't equal these points right here. It doesn't equal those. Okay, so that's why I'm putting the parentheses around it. I mean, not the parentheses, but the open circles. And then we need ones that are greater than, so those are going to be the pluses. So it's going to be right here. So the answer to this, I had to kind of, I made a typo, and then so I'm back here again. I have a pretty good software that does these recordings. So the answer to this is going to be x is less than -2, or x is greater than 2/5, because it starts over here, it goes in that direction, so it's going to be less than -2, and it starts at 2/5, and it's all the numbers that are greater than. Okay, good job. Next one, we're going to use the sign diagram to solve this, and let's go ahead and use the lavender. Okay, so we need the right hand side to be 0, and I'm going to distribute these so I can go ahead and eventually factor the trinomial. Plus 12 minus 17x is less than 0. Let's put that in standard form. Yeah, somebody scared me today in class saying that. What's standard form? Scary times, guys. Okay, now let's go ahead and factor. And I've used trial and error all of my life. I've just been introduced to the new methods that some of the kids use, that they learned from like videos online, or since I've been teaching. But since I was a student, I've always used trial and error, and that's kind of beneficial for me because now I've used it so many times that it's the easiest method for me. I just know patterns, and so okay, so let's go ahead and I'm going to split this 3x and 2x. And the reason is because this number in the middle is not that big of a number. But if I keep the factor, the a factor as 6, 1, then the 6 is going to make it, if I multiply anything that is a factor of 12, then it's going to make that a really big number. So I know that when we are adding these two, the middle two terms, it's not going to be that big of a number. 17 is not that big of a number compared to 6 and 12. And then I see the factors of 12 is, it could be 12 to 1 or 6 to 1, and then 3 to 4. I mean 6 to 2. 12 to 1 is going to be too big. It's not going to work. And I could try 12 plus 3, and that's only 15. 6 and 2, I mean, I can do 2 times 3, which is 6, and then add 6 to that, and that's 12. So I can kind of do these in my head now without actually writing them down. And that's one of the disadvantages if you use a different method. For me, trial and error is the fastest method for me because I've used it for such a long time. Now, if I'm going to use 3 and 4. I'm going to use 3 and 4. But if I put a 3 here and a 4 here, to me, this doesn't make any sense. That means that I have to factor out 3. I can actually factor a 3 out. That means initially for these 6, 12, and 17, that I should have been able to factor out a 3, and I just didn't. And so that's not true. And so I know that that is not the placement of the 3 and the 4. Okay. I'm into my lavender. So I'm going to put the 4 and the 3. That is not lavender. Well, that kind of looks cool with the brown and the lavender. Okay, so let's go ahead and say x equals 4 over 3 and x equals 3 over 2. I'm going to make the brown kind of doesn't show up. Let's go ahead and do orange. Yes. Okay, these autumn colors. We can do 4/3 is going to be like 1.3 repeated, and then 3/2 is 1.5. So I can try some points like x equals 0, x equals 1.4, and x equals like 5. And when I try those, I know it's going to become a plus, minus, and a plus. And these points, these critical points, since this is not equal to, I know that's why it's going to be an open circle. So I have to look for things that are less than 0. So it's all of this stuff in the middle. Okay, so my answer is going to be x is between 3/2 and greater, or less than 3/2 and greater than 4 over 3. Okay, I could make it x is less than 3/2 and x is greater than 4/3 if I wanted to. You can write it that way if you don't want to write it as a compound fraction. And remember, these are intersections, so they have to kind of, the x has to satisfy both of these conditions. Whereas this is an or. It can satisfy this or this. It's conditional. It's just one condition. Okay? So if I were to draw these in a Venn diagram, these and things are the ones that would overlap. And this or would be on the either side of those circles. Okay? Next, good job. Number 3. Okay, now we have to have the right-hand side be 0. Okay, so I'm going to change the color. So x plus 2, 2x minus 3, minus 1 is less than 0. We always have to have it less than, the right-hand side, or one of the sides, 0. So we have x plus 2. Okay, x plus 2, and then 2x minus 3. Common denominator will be 2x minus 3 over 2x minus 3 less than 0. X plus 2 minus 2x minus 3 over 2x minus 3 is less than 0. Let's go ahead and distribute. X plus 2 minus 2x plus 3 over 2x minus 3 is less than 0. Move that up to there. We have a negative x plus 5 over 2x minus 3 is less than 0. So now once we have it as one fraction, we can kind of figure out the critical point. So negative x plus 5 has to equal 0. That's one critical point. And 2x minus 3 equals 0. That's another critical point. So that implies that x equals 5. And that implies x equals 3 over 2. Okay, now remember this, the numerator makes that fraction 0. Okay, well, if x equals 5, then it equals 0. Okay, 0 is actual number. Okay, but here is where the denominator can make it undefined. Okay, regardless, since this inequality is not asking for equal to, it's not asking for an equal to, both of those on the sign diagram are not going to work. So we have a set of 3/2 and a 5. So I could try x equals 0, x equals like 2, and I'm going to try x equals 6. Okay, 0, so that's going to give me a 0, negative, and a negative, right? Negative and a negative. So negative and a negative, let me just go ahead and do this. Negative and a negative, so that's going to give me a positive, and then that is going to give me a positive over a positive. What? I think it is getting late because I'm making a lot of mistakes. Okay, so this is wrong. Sorry, guys. Okay, so that 0, 0 positive, 0 negative. Oh, so this is going to be positive over negative. So that's going to be negative. 2 is going to give me a negative 2 positive over a positive. So that's going to be a positive. And then after this, it's also going to give me a positive. Nope. It's going to give me a negative over a positive. So it's going to give me a negative. Now remember, this was the asymptote right there. So I'm going to put an open circle there. And that was the y-intercept. I mean, that was the x-intercept. But this doesn't equal right here. This right here does not equal 0, which tells me that that's also going to be an open circle. I'm going to look for things that are less than right here, right there. Okay, so that gives me, oh, I think I did this with somebody and we both got the wrong answer. I can't remember who. Might have been Allie? Was it Inesh? I don't remember. Okay. But anyways, make sure you watch the video. So x has to be less than 3/2 or x has to be greater than 5. That's the correct answer for this. I don't really like those Christmas colors right there, do you? Good job. Next one. Wow. Why does that look so big? Okay, so this is already set equal to 0. The two critical points, this looks so big. The two critical points are going to be this numerator set equal to 0, and then the denominator set equal to 0. And then I'm going to go ahead and solve x squared. We're going to square root both sides, gives you the sign plus or minus. X equals plus or minus 1. So I get 3 critical points, 0, -1, and 1. I'm going to test x equals negative, doesn't matter. X equals -5. I can test that. Let's put that in a different color. X equals -5. I'm going to test x equals -0.5, and I could test x equals 0.5, and then I could test x equals 2. Okay, by the way, this is less than or equal to. These two right here are the asymptote. That is the x-intercept. That doesn't show up very well. Let's go ahead and make it red. Those are going to be the asymptotes. That 0 is going to actually be equal to 0 because that's the numerator. Okay, now when I put a -5 in, it's going to be a -5 positive. So this is going to be a negative. -0.5 is going to be a negative on top. 0.5, no matter 0.5 squared is going to be smaller number than 1. Okay, because it's 1/2 squared. And any kind of fraction squared is going to become a smaller number than 1. Okay, that's proper fraction. Okay, so that's going to be a positive. Oh no, it's going to be a negative. Why am I having such a hard time doing that? Oh yeah, because I did 5 hours of tutoring and watched a play, which was phenomenal, by the way. The play was pretty amazing. And I just ate, took a shower, and I'm in front of you making a video. Okay, and then this is going to be a plus, and that's going to be a minus, so that's going to be a negative. And then that's going to be a, is that going to be a, that's going to be a positive, and 4, that's going to be a positive. I think I explained to somebody this is wrong also. I mean, incorrectly also. Or I just looked at it and say, yeah, that looks right. But I actually don't know unless I make a key. Because, you know, Okay, so we need ones that are less than. So it's going to be over here. Wow, this is some ugly color combination. Okay. And then that means my inequality is going to be x is less than -1, not equal to, or x is between 1 and equal to 0. Okay, that is some horrid color combinations. Remember, it equals 0 because the numerator could be a 0 right there. That could be a 0. X could equal 0 right there. Okay, good job. Next one. Find the domain of function using the sign diagram. I already know this is going to be a long video. Okay, so how to find the domain, okay, in a radical. So if you look at this radical right here, okay, it's 1 over, I don't like this color. It is, let me go ahead and move this down like that. Oh. Now it's better. Okay. Let's take a look. So what can the inside of that radical not be? How do you make that undefined? First, it can't be a 0 because it's in the denominator. So the radicand can't be 0. And the radicand also can't be negative. Okay, so I could take that entire thing out, like 3x squared minus 7x minus 20. That entire thing has to be greater than 0. So when it's greater than, I'm sorry, I'm just trying to change colors because I'm trying to liven up my mood. When it's greater than 0, okay, then everything, all the numbers work. Positives work. Okay, we can have even an irrational number, but an irrational number would still work. Like a square root of 2 will still work. Square root of 3s will work because it's actually a number that's located on the Cartesian coordinate. Okay, so we have a 3x and an x, and then let's see, a 5 and 4. I'm going to try the 5 here and the 4 here, and then I'm going to make this a minus and a plus. So it's -12 and +5. We're subtracting those two, so we get 7. Okay. So we get x equals -5 over 3 and x equals 4. So domains are, hey, what can I put into this function and it'll work? It won't mess up the function machine. Okay. And what works is everything inside of that radicand right there, everything inside of this radicand right there has to be greater than 0. And then we have the 4. Okay, and the numbers that I'm going to test out are x equals, I can test out x equals, let's do like -4, x equals 0, and x equals 5. -4, when I put -4 in there, it's going to be a -12. So that is going to be a negative times a negative. So that's going to be a positive. That's going to be open circles right there. And then if I do a 0, that's going to just give me the y-intercept, which is a -20. And then a 5, that is going to give me a positive. Greater than 0. Ba-bam, ba-bam, ba-bam. If I try 0 in there, that's going to make it -20, right? Because this is going to turn into 0. That's going to turn into 0. 0 multiplied by anything is 0. So it's just going to leave me with this -20. And 1 over the square root of -20 1 over the square root of negative 20 is undefined because that's an imaginary number. It's not undefined, but it's an imaginary number. It doesn't belong on the Cartesian coordinate. Okay, and so that's the domain. So the domain of this, and you can put it in, I mean, you can do x such that x is an element of all real numbers, and then go ahead and put, that's the proper way to write a domain, right? X is less than a negative 4, or x is negative 4. Yeah, you're going to be getting like maybe 75% of Miss Alstrom right now. Negative 5 over 3, or x equals 4. Oh no, goodness, what in the world am I doing? I'm sorry guys. X is greater than 4. That's the proper way to write a domain, isn't it? Wouldn't you think so? Isn't that what I taught you? Okay. Yeah, somebody asked, could we just write the inequality? And now I realize, no, you can't. I don't know. Maybe I'll count it. Okay, now let's look at this radicand right here. It's different. It's in the numerator. I mean, it's not in the denominator. So that means that entire radicand could equal, it has to be greater than 0, but it could also equal 0. It could also equal 0. Okay, and so let's go ahead and just factor x minus 4 is greater than equal, oh, I feel really pastel-y today. X equals 0, x equals 4. Put that on the number line. We have a 0, we have a 4. And then see how yellow shows up. X equals negative 1, x equals 2, x equals 5. Okay, now that equals, right? So that means that these two are actually, they'll work because they'll turn that left-hand side 0. Okay, so negative 1 is going to give me a negative times a negative, so that's going to give me a positive. 2 positive and a negative, so this is going to give me a negative. 5 positive and positive, so a positive. So greater than, it's going to be all of this, all of that. So x is an element of all real numbers, greater than, so x has to be less than or equal to 0, or x has to be greater than or equal to 4. And that right there, my friends, or my students, is the final answer. Okay? Good job. Good job. One of the, I don't really like tricks. I want you to actually think about how you got this. But if you have a radicand in the denominator, if you have a radicand and you need to find the domain, just remember, whatever this radicand is, the domain of it, radicand, it has to be greater than 0. Because it can't be 0 and it can't be a negative. If you have just a square root and a radicand, such as this, okay, just like number 6, then you'll have to have a radicand that has to be greater than or equal to 0. Okay, good job, guys. Okay, it says describe the end behavior of the polynomial functions. Now, I noticed that some of you guys were making little tables, but remember, okay, you either have an even or an odd function. Okay, and how do you know? Even functions, the leading, so if you put for example, number 8, this is in standard form, negative 7x squared, x cubed, plus 2x squared, minus 3474. What you really need is that first term in standard form with the exponents in decreasing order. Okay, what you need is the leading coefficient. Okay, my cat's eating and she's eating too fast. You need the leading coefficient, and you need the degree or the highest exponent. Leading coefficient and the highest exponent. Then you will figure out if it's even or odd. Okay, leading coefficient is either going to be a positive or a negative. The degree is going to either be a even or an odd. Okay, so this is where you get it from, that highest exponent, even or odd. So an even could have a positive and it could be a negative. Okay, it could be a positive and it could be a negative. Keep on going to that pink. No, the pink is going to look not very pretty. Either a positive or negative. So if it's an even function, for example, like x to 178 or x to the 12th or whatever, just remember it's all going to look like a quadratic. They're all going to look like a quadratic. It's either going to be an open a concave up parabola or a concave down parabola. And the end behavior, just the ends, are going to look like a quadratic. So in a quadratic, if the leading coefficient was a positive, then the ends would have looked like that, right? It opens up or concave up. So as x approaches positive infinity, right here, y approaches positive infinity. And as x approaches negative infinity, y approaches positive infinity. For a negative coefficient, I don't care what happens in between, but it's going to look like that. So for this, as x approaches positive infinity, y approaches negative infinity. And as x approaches negative infinity, y approaches negative infinity. And that's going to be for all even functions. Treat it like a quadratic. Okay? Now for an odd. Odd could have a plus positive coefficient, leading coefficient, or a negative leading coefficient. With an odd function, you can have like x to the 277 or x to the 17th. Treat all of them like a linear function. So a positive slope, it could have some stuff in the middle, is going to look like this. As x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. With a negative leading coefficient, we're going to treat it like a negative slope, like that. Okay, as x approaches positive infinity, y approaches negative infinity. As x approaches negative infinity, y approaches positive infinity. Okay, when you realize that, when we could see just those linear functions are going to be odd with a positive negative slope. And then a even function is going to be like a quadratic that's going to be concave up because it has not been reflected over the x-axis, or it's concave down because it has been reflected over the x-axis. Hence, the a value is going to be a negative. Once you realize that, then these become very easy. So for number 7, let's go ahead and do yellow. Okay. No, not yellow there. Okay. For number 7, and all we have to really pay attention are the leading terms, just like those. Okay. So that's x to the 1 times x to the 2nd. So that's going to give you x to the 3rd, and it's a positive 1. So that means, okay, so x, it's an odd and it has a positive. So think of it like that, like a positive slope. So as, I shouldn't have drawn that right in the smack dab center. Like this. Sorry. Oh, my computer froze. Like this. Dot, dot, dot. Like that. So as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y approaches negative infinity. Negative infinity. Okay? For this one, x cubed, that's going to be odd, like a linear function, and has a negative slope. So it's going to look like bam, bam, bam. Kind of like that. So as x approaches positive infinity, y approaches negative infinity. And as x approaches negative infinity, y approaches positive infinity. Okay? Next, let's take a look at this. I am just going to look at those first terms. So that's x to the 1, 2, 3, 4. X to the 4th. I'm going to multiply the coefficients. -1 times -2 times -1 times -1. So it's going to give me -2. So it's going to be a negative and an even. It's going to be a concave down parabola. It's going to look like that. So as x approaches positive infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. Okay? Good job. Next. Let's just look at the first terms. So negative times a positive, that's going to be a -1. X to the 2nd times x to the 2nd, we add the exponents like that. Once again, that's going to look like a concave down parabola. So as x approaches positive infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. Okay? Good job, guys. So these problems, number 11 and 12, are kind of interesting. They talk about theorems that like 1 page on the notes. Most of you guys didn't, I noticed that you guys didn't pay attention. But basically, number 1 is something called the remainder theorem. And it says that the remainder of whatever the factor is Okay, whatever you divide by, the remainder of whatever you divide by is actually the output of that factor when you solve for x. So what do I mean by that? So when we take 2x to the third plus 4x minus 5, and we divide it by negative x minus 2. When we do synthetic division, remember we have to set this equal to 0, so we have to actually do synthetic division of 2. Okay, so that tells us that when I input this into the 2 into the function, or substitute it for x, then the output is going to be the remainder. So, for example, if this was the function, like that, and if I inputted a 2 in here, and that's going to be 2 times 8 plus 8 minus 5. So that's going to be 16 plus 3. So f of 2 equals 19. So that tells me that that output, when I input 2, is going to give me, is the remainder when I divide by it. So the remainder for this is going to be 19. And that also means that the point 219 belongs on that graph. Okay. Now, for number 12, I can do synthetic division. Well, it tells you to do synthetic division. One of the things, when the remainder is 0, for example, if I put in, let's say if I put in f of 1 into that function and I get a remainder of 0, that means that that point is 1, 0. That means that that 1, 0 is going to be the x-intercept when the remainder is 0. So when we do synthetic division to find the roots and we get that remainder of 0, that tells us that that is an actual root. And that's where the remainder theorem is used. Okay? It's just that we are kind of rushing through these. I'm sorry, guys. So number 12, divide using synthetic division. So x minus 1 over 4 equals 0. X equals 1/4. There is my divisor that I'm going to use for making sure. I always put x cubed, x squared, just to make sure that I didn't leave anything out. X, and then 2. Bring down the 4, multiply. 1, negative 8. That's going to be negative 2, and then negative 8, and then negative 2, and that's going to be 0. So when I divided using synthetic division, my remainder was 0. When the remainder is 0, okay, you know that that point 1/4, 0, is a part of that polynomial. That's an x-intercept. That means that x minus 1/4 is a factor. It's a factor because the remainder is 0, and x minus 1/4, when I set it equal to 0, x equals 1/4, and that's the x-intercept, or the root of that polynomial. Okay? Good job, guys. Okay. Just gonna... Okay, so number 13 is kind of like a step-by-step. It's kind of like a step-by-step way of solving this. So let's go ahead and do that. Okay. Use the Descartes rule of signs to determine the possible positive zeros and possible negative zeros. So to find the Descartes rule of signs, first we look at f of x, the function itself. and I look at the sign change. No sign change there, no sign change there, and no sign change there. So the possible positive zeros are going to be 0. Okay, to find the possible negative zeros, I have to substitute negative x cubed. And then I'm going to simplify. That negative x cubed plus x squared minus x and plus 1. One sign change, 2 sign changes, 3 sign changes. So possible negative zeros are going to be 3, and then we reduce this down to 2, so it's going to be 1. Okay, and the reason is that the polynomial function, I mean, for example, this is an odd function, so it's going to end up looking like with a positive, so it's going to have this, but I mean, it could have 3 negatives right here, 1, 2, 3, 1, 2, and then it could go like that, or it could have 1, but it can't have 2 because the loops, the amount of loops is not going to allow it to end in the end behavior that it does. Okay, and that's where the 3 and subtracting it by 2 comes from. Okay, I don't think I've explained that thoroughly, but you know, I'm already running 47 minutes into this video. Okay, now possible rational roots. That's where we do the P over Q. So I'm going to find P. P is 1 right here. Remember, the constant goes on top. Okay, and then Q is going to be 1. So that is going to be plus or minus 1. This is going to be plus or minus 1. So P over Q is going to be plus or minus 1. Find all the rational roots. Well, it could only be 2. So I'm going to try to put 1, and it is going to be 1, 1, 1, 1, just like that. Bring down the 1, 1. Nope, that's definitely not going to work. It has to have some negatives in there. So negative 1, 1, and then I had a negative 1, 0. Negative 1 times 0 is 0, 1, negative 1, 0. So it started at x to the cube. Now it's going to reduce it down to x to the square. And so I have an x squared plus 1 equals 0. I know that's not going to factor. In fact, I can actually solve this. So the only rational root that you have is x equals negative 1. Okay, that is going to be an imaginary root because find all the other roots. Now that's where x squared plus 1 it comes in equal to 0 comes into play, and we're just going to solve. Okay, so x squared square root equals plus or minus the square root of negative 1. So x equals plus or minus I. That is all other roots. Describe the end behavior. Okay, this is a odd function. It has a positive leading coefficient, so it's going to have a positive slope. It's just like a linear function that has a positive slope. So it's going to look like that. So as x approaches positive infinity, y is going to approach positive infinity, and as x approaches negative infinity, y is going to approach negative infinity. Factor completely, including rational and complex numbers. So I'm going to gather all my roots. X equals negative 1, and I'm going to write them separately. So this is I, and x equals negative I. And then I'm going to have the right-hand side equal to 0. I'm kind of going backwards here. Instead of actually looking for the roots, I'm putting it back into factors. So that's x plus 1 equals 0. X minus I equals 0. X plus I equals 0. Those are the factors. X plus 1, x minus I, and x plus I. I really do have a great set of kids this year for pre-calculus. Yeah, I'm very lucky to be your teacher. Even though I'm doing a lot, I know that you guys are good kids, and yeah. Anyways, I don't want to get all sappy. But anyways. Okay, so number 14 is a very typical, like, high possibility problem that I'm going to have on the test, because it's only to x to the cube, and that means that there's only 3 possible roots, or there's only 3 roots, and so that is very doable in the time period that we're going to have this test. Now, something like number 15, I don't think I'm going to have time to do have on the test, but I want you to be able to kind of work through it, because it involves a lot of things that just practice that you're going to need for the test. So the very first thing is I look for the possible roots, which is the p over q. Now, the p equals 3, which means that that is going to be plus or minus 1, plus or minus 3. And q equals 2, so that's going to be plus or minus 1, plus or minus 2. So p over q is going to be plus or minus 1, plus or minus 3, and then plus or minus 1/2, and plus or minus 3/2. Okay, now, I mean, I could do the Descartes rule of signs if I wanted to, or I could just quickly do the positive ones. One sign switch from here, and then another sign switch from here. So I could have possible positives 2 or 0. Okay, so let's go ahead and do that. If I wanted to do the negative, it'd be a negative and a negative and a positive and a positive. So just one sign switch. Okay. So since there's more possibility of having 2 positives, I'm going to try a positive 1. Let's try a positive 1. Okay. That's going to be a 2, negative 5, negative 4, and a 3. 2, 2, negative 3, negative 3. I already know it's not going to work. Negative 7 is not going to give me what I want. Okay, so let's go ahead and try a 3. 2, 6, 1, 3, negative 1, negative 3. Voila. So I've gotten it down to a quadratic. Okay, now I can continue doing this, but I want to know if it's factorable. If it's going to give me rational roots. So I can use the discriminant of the part of the quadratic formula. And if it's a perfect square, if that discriminant is a perfect square, then I know that it's going to be factorable. So 1 plus 8, yep, it's going to be factorable. So I can set this equal to 0. And you can continue doing the synthetic division with the possible roots that you started off with. You can do it if you wanted to. But since factoring is easier for me, I'm going to do that. So I have a negative 1 and a positive 1. Right? Negative 2. Yep. So that's going to give me x equals negative 1/2, x equals 1. So all my roots for this is going to be x equals 3, -1/2, and 1. Was my Descartes rule of signs right? Did I have 2 positive roots and 1 negative? Yes, I sure did. Okay. Number 15. Good job, by the way, on number 14. Number 15. Find all roots rational and complex for this function if x minus 2 is one of the factors. So if it's one of the factors, I know that the remainder is going to be 0. But when I divide this x squared minus 2 into here, what it does is give me, since I'm dividing x to the second into x to the sixth, it's going to give me an x to the fourth polynomial. Okay, quartic polynomial, I think. Okay, so that's what I'm going to do. I'm going to do long division on this. X to the sixth plus third plus x squared. Oh, wait a second. I'm gonna write. I'm missing some terms right here. Plus 0 x to the fifth plus 0 x to the fourth plus 8x cubed plus x squared minus 16x minus 10. So I have a x to the fourth when I divide the first terms, x to the sixth. I wonder why my computer just freezes periodically. Probably because it's brand new. I have no idea. Okay. X to the fourth, x to the sixth, minus 2x to the fourth. So I'm going to put it where x to the fourth belongs. Subtract plus. Do that. So we have a 0 x to the fifth, and we have a 0 x to the sixth too. I could just leave that x to the fifth off. I don't need it if we're starting off with a 0. So I guess it kind of defeats the purpose of filling it in, but sometimes we don't know if there's going to be an x to the fifth that we need to add or subtract this x to the fifth with. So I just put it on there, okay? So 2x to the fourth, and I bring everything down. Not just one term. I bring the entire thing down. With something like this, where the divisor has missing terms, I bring everything down. And then we have a plus 2x to the second. Let's go ahead and multiply that through. 2. We have a 2x to the fourth minus 4x to the second. Minus 4x to the second. Christmas colors. The green is for me distributing the negative across. So bring down this 8x cubed plus 5x squared minus 16x minus 10. That's going to give me a plus 8x. So 8x cubed minus 16x distribute the negative through. Bring down this 5x to the second. That goes away. Minus 10. We're just going to add a 5 here. And that's a 5x squared and a minus 10. Distribute a negative. Negative 1. Like that. and that is a remainder of 0. And I need this quotient. Use the quotient. Use the quotient. I'm going to use that quotient. How am I going to use that quotient? Okay, use the quotient to set it equal to 0. Now I'll do P over Q. It's going to be plus or minus 1, plus or minus 5. So I'm going to set up 1, 0. X to the third is going to be 0. This is x to the third, x to the fourth. 2, 8, and 5. And we have a 1. Let's try a 1. I don't think a 1 is, I'm going to try a negative 1. Negative 1, 1, negative 1, negative 1, 1. That's going to be a 3, negative 3, 5, negative 5. It worked. That started out with an x to the fourth. That's going to reduce this to an x to the third. It's not enough for it to be a quadratic. So I'm going to go ahead and continue to do this. I can try 5 if I wanted to. 1, 5, 4. That's going to be too big. And I don't see any negatives appearing. And then remember, these have duplicitous. Okay, these are fake numbers. Okay, they can have multiplicity. So I'm going to try negative 1 again. 1, negative 1, negative 2, 2, 5, negative 5. Voila. Now this is going to be reduced down to a quadratic. Okay, and if I look at the discriminant, b squared minus 4ac, what that does is negative 2 squared minus 4 times 1 times 5. So 4 minus 20, which is negative 16. And that is not going to be factorable. So I'm going to use the quadratic formula. One of the good things about using the discriminant to check is that it's part of the quadratic formula. So you could just put it right into that. You can use it as a radicand. X equals 2 plus or minus, and that is 4i over 2. So x equals 1 plus or minus 2i. One plus or minus 2i. Okay, so let's go ahead and find all the roots. The roots are going to be x equals negative 1, negative 1, negative 1, negative 1, multiplicity of 2, and then also x equals 1 plus or minus 2i. And then don't forget this up here, x squared minus 2. We also have to do that. So to find x squared minus 2, we set that equal to 0. X squared equals 2. Square root x squared equals plus or minus the square root of 2. X equals plus or minus the square root of 2. Okay? So x equals plus or minus the square root of 2. Well, no, I don't want to. Gary's giving medicine to my cat right now. Okay. It has 1, 2 rational roots, 1, 2 complex roots, 1, 2 irrational roots, a total of 6 roots. It's a 6-degree polynomial. It has 6 roots. This is perfect. So once again, I am not going to have something like this. It takes too long to do it on the test. But doing number 15, you practice so many different skills. And I think it's very helpful for you to, do it. Okay. It's nice. I have my incense burning and a cup of green tea sitting here around 8 o'clock at night making these videos. I got some new incense from Korea. It's the kind of camping one where it comes with a clip and it's pretty cool. Okay, so number 16, find all roots and factors. Okay, wait a second. Oh, number 14 and 15 just said roots. Now, so I'm going to use possible roots, P over Q. So P, enough of the red. Blue, P equals 8. And Q is going to equal 3. So that means it's plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8, plus or minus 1, plus or minus 3. Okay. Now I am going to do P over Q. Tells me it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then P over Q, denominator, make it 1/3, plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, and plus or minus 8/3. Okay. Next, we can use Descartes' rule of signs if we want. I'm just going to do the positives just to figure it out. That is 1 sign switch, 2 sign switches, so 2 and 0. Okay, for the positive. Negative, it's going to be the same. It's going to be 2 or 0. Okay, that doesn't help me much. So let's go ahead and set up my synthetic division. 3, 0, and then negative 14. Where did the 0 come from? I like to once again write x to the 4th, x to the 3rd, x to the 2nd, just to keep me straight. And then that's the constant. Okay, let's try 1. Bring down the 3. I have no idea why I rewrote it. Bring down the 3. 3, 3, 3, negative 11. I don't think so. Let's try negative 1. 3, negative 3, negative 3, and then 3, negative 11. How in the world is the same as the... Did I do the 1 wrong? I'm sorry, guys. Let's try 1 again. 3, 3, 3, 3. No? I think negative 1, and I think it was negative 3 and then negative 14. So that doesn't work. Let's try 2, 3, 6, 6. It's getting closer to the negative 14. 12, negative 2, negative 4, negative 4, negative 8. Yay! Okay, now that reduced it down to x to the 3rd. It's still not enough. Let's try 1 more. Now I have a positive. Okay, so I know I'm going to have another positive. Now it's just a matter of finding. 1 didn't work, so let's try 4. 3, it's going to be a 12. Let's try an 8. Is 8 going to work? That's going to be too big. Let's try some of the fractions. Before we try the fractions, I know it said 2 positives and 2 negatives, which tells me that it might have another negative root, but the positive that is going to be the total that makes up the 2 might be an irrational. So I'm going to try, I already tried -1. I'm going to try -2. Okay. 3, -6, 0. That's a 0, -2, and then a 4. So a 0. Now, it's a quadratic, -2. There is, and I could just solve this. Why am I rewriting that? Because it doesn't have a middle term, so I could just solve for x. Equals 2 divided by 3, x squared. Yikes. Equals 2 over 3, and then we're going to square root plus or minus square root 2/3. So x equals plus or minus square root of 2 times the square root of 3. I'm going to get rid of that square root of 3 in the denominator. You have to rationalize it. 3. So the roots are 2, -2, and this irrational. So my roots are going to be x equals 2, -2. You can write that as plus or minus the square root of 6 over 3. And then to write the factors, -2, x equals square root of 6 over 3, x equals negative square root of 6 over 3. And then I'm just going to make the right side equal 0. Factors would be x minus 2, x plus 2, and then it is x minus the square root of 6 over 3, and x plus the square root of 6 over 3. And since factors involve parentheses, like that, and there's multiplication in between the parentheses, if you wanted to just express the x minus square root of 6 over 3 and the plus or minus of that as this right here, 3x squared minus 2. I mean, isn't that a factor? Isn't it though? Yeah, it kind of is. So, I mean, I would think that that's right. I would think either one of these. I mean, the roots are this, for sure. But I mean, by definition, those are in factored forms. So if you want to get all technical, okay. Now, 17, find all roots and factors, rational and complex. And then if x equals 2i is one of the roots. Well, if x equals 2i is one of the roots, then we know x equals 2 minus 2i, because it's the conjugate, is also one of the roots. So if I take this and I rewrite it, x minus 2i equals 0, x plus 2i equals 0, and those two are factors. And if I want to figure out what that is, I could just multiply the two, x squared, and then minus, those are conjugates, so minus 2i plus 2i, that's going to not have a middle term, minus 4i to the second, so x plus 4, x squared plus 4. Okay, and then I could do the same thing where I can take that and I can divide this. For x to the 6th plus 0 x to the 5th minus x to the 4th plus 0 x to the 3rd minus 64 x to the 2nd plus 0 x plus 16 x squared. And then once I do that, this is going to be fun times, right? 4x to the 4th, 4x to the 6th, plus 16x to the 4th, plus 16x to the 4th. Distribute the negative. Is 0, 0. Negative 17 x to the 4th plus 0 x to the 3rd minus 64 x to the 2nd plus 0 x plus 16. Okay, and then that's going to be a minus 17 x to the 2nd minus 17 x to the 4th, and that is going to be a minus 17, no, what's 4 times 17? It's turning into a mess over here. 4 times 17, it is, can't see, 68 minus 68 x to the 2nd. Distribute the negative, so that's going to be a positive and a positive, so that you don't need to bring down that 0x to the cubed. So that is a positive 4x to the 2nd plus 0x plus 16. And then that is going to be a positive 4x to the 2nd. And then that is going to be a plus 16 minus, well, let's write that in a different color, and a negative. Remainder of 0. Now we need this quotient. We need that quotient. So that 4x to the 4th minus 17x to the 2nd plus 4. Let's go ahead and find 4, 0, x to the 3rd. This is x to the 4th, x to the 3rd, negative 17, 0, and 4. What numbers to try? P over Q. P over Q is going to be plus or minus 1, plus or minus 2, plus or minus 4. When Q is 1, plus or minus, when it's 1/2, plus or minus, when it's 2, 1/2, 2 over 2 is 1, That's going to be 2. When it's 4, it's going to be plus or minus 1 over 4, plus or minus 1/2, and plus or minus 1. So that's all it could be. And then let's go ahead and try a 1, 4, 4, 0. What am I doing? It's a 4. 4, 4, negative 17 minus 4 is 13. That's not going to work. Let's try a negative 1. Negative 1, 4, negative 4, and that is a negative 4. Negative 4, 4. That's still not going to work. It has to be a larger number. Let's try a 2, 4, 8, 8, 16, negative 1, negative 2, negative 2, negative 4, and 0. And that's going to be x to the 3rd. I'm going to continue. 2. Let's go ahead and try negative 2. 4, and then negative 8, 0, 0, negative 1, and 2. So that's now going to be x to the 2nd. So 4 x to the 2nd minus 1 equals 0. Now I can take this. X squared equals 4. No, what am I doing? It's going to be 1 over 4. And then x squared, square root both sides, get the plus or minus, square root of 1/4. X squared is plus or minus 1/2. So all of them ended up becoming real. I mean, the rational. So let's gather the roots. Wow, they're all spread out all over the place. All spread out. Okay, at first they told us that that was one of the roots. We determined that the conjugate has to be another root. And then we found that quotient, and then we did the synthetic division. There you go, there you go. And then finally, these two. And so the entire roots of this are going to be x equals plus or minus 2i, and plus or minus 1/2, and plus or minus 2. Now, if I want to put those in factored form, I can put x equals 2i, x equals minus 2i, x equals, we had 1/2, x equals negative 1/2, x equals 2, x equals negative 2, x minus 2i, x plus 2i, x minus 1/2, x plus 1/2, x minus 2, and x plus 2. So it could look like x minus 2i, x plus 2i, and then For 1/2, you can write it as 2x minus 1 if you want. 2x plus 1 and x minus 2 and x plus 2. You could just put these together, and at the beginning we had the x squared plus 4, so you can put x squared plus 4 if you want, and it'll be 2x minus 1, 2x plus 1, x minus 2, x plus 2, or there you go. I'm going on 1 hour and 25 minutes of recording. Whew. Okay, find all roots and factors. So let's go ahead and do Descartes' rule of signs. We don't have, wait a second. Oh, first of all, we can factor out a x. Nice. 2x to the third plus 3x to the second minus 3x minus 2. Okay, and then we can say this is x equals 0, 2x cubed plus 3x squared minus 3x minus 2 equals 0. And then we can do p over q. So plus or minus 1, plus or minus 2, and then the denominator of 2 plus or minus 1/2. Okay, let's go ahead and set up our 2, 3, -3, -2. I'm going to try 1. Okay, and then that becomes 2 and 2, 5, 5, and 2, 2, and 0. So that becomes a quadratic, and now we could either use the quadratic formula or we can factor. So I'm going to see if it's factorable. And then 5 squared minus 4 times 2 times 2, 25 minus 4 times 4 is 16. It's 9. Yes, it is factorable. Ba-bam. 2x plus x plus 2, 1. There we go. X equals -1/2. X equals -2. Okay. Yes, we found all the factors. All the factors is x equals 0, 1, -1/2, and you can write these in order. And then the factors are going to be, yikes, x, and then x minus 1, x plus 1/2, or 2x. Let's go ahead and rewrite it like that, and x plus 2, and that's going to be 2x plus 1, x plus 2, x minus 1, and x. There you go. There you go. Okay. This one tells us to the 5th root. I'm going to first take out an x, so x to the 4th plus 3x to the 2nd minus 4 equals 0. So x equals 0 is one of them. X to the 4th plus 3x to the 2nd minus 4 equals 0. I'm going to do p over q. Straightforward. Denominator is going to be 1 plus 4. So I'm going to try 1 here. 1, x to the 4th, 0, x to the 3rd, 3, x to the 2nd, x is going to be a 0, -4, 1, 1, 1, 1, 4, 4, 4, 4, 0. that reduces to x cubed. Right? Yeah, so we have to keep on going. Let's see, I tried 1, but we can try 2. 0, no. 1, 2, 3, 6, 10. Nope. No, 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 no. Let's try -1. 1, 1, -1, 0, 0, 4, -4, 0. There we go. X squared plus 4 equals 0. Let's go ahead and solve that. X squared equals 4. Square root of x squared equals plus or minus. That's a -4. Square root of -4. So x equals plus or minus, and that's 2i. So all of our roots, gather them up. 0, 1, -1, plus or minus I. So the roots are going to be x equals 0, plus or minus 1, plus or minus 2i. The factors are going to be x times x plus 1, x minus 1, and then here I can go ahead and do x equals 2i and x equals -2i, and just set that right hand side equal to 0, x minus 2i, and then x plus 2i. And so x minus 2i, x plus 2i, or I could just put x, x plus 1, x minus 1, and then I could just put this down right here, x squared plus 4, plus 4. Like that. Good job, guys. Okay, it says solve the polynomial equation, including all rational and complex. So we're just solving. We're not actually factoring anything. Let's see. Let's go ahead and solve these. How am I going to solve this x to the 4th minus 5x to the 2nd? So to solve it, basically, we're just going to, I'm kind of getting tired. Okay. To solve it, we're going to be doing the same thing we did, which is p over q, except we just don't have to put it in factors, plus or minus 1. Gosh! Plus or minus 2, 3. Oh gosh, this reminds me so much of high school, that we had something like that. 3 times. This is so many factors is 36. I'm getting kind of scared. 36 divided by 4 is 9. No, not 5. 6, 9. Why did I do this myself? Repeated it. Okay, so 3 and then 12. 36 divided by 2 is 18, plus or minus 36. Now we just have to get down to a quadratic. Thank goodness. Okay, thank goodness we just have to get down to a quadratic. Is there any other? No, gosh, why am I doing this? I'm sorry. Yeah, I'm sorry about that. I mean, remember, hey, you remember how to do these. Remember, we substituted u equals x to the 2nd? Oh, yeah, we could have done it like that, Miss Hallstrom. So we could do u squared minus 5u minus 36 equals 0. So u plus u minus 36. Oh, was that 4? Yeah, 4 and 9. Yes. 9 and 4. Yes. And so that becomes x squared plus 4 and x squared minus 9 equals 0. And we have x squared plus 4 equals 0. X squared minus 9 equals 0. X squared equals negative 4. So x squared square root plus or minus square root negative 4. So x equals plus or minus 2i. X squared equals 3 square root x squared. Oh, whoops. I got a little ahead of myself because I was very excited to realize that this is what we've been doing in class. Plus 9. So x equals plus or 3, 9. So x equals plus or minus 2i and plus or minus 3. Nice. Nice. Okay, let's just factor out an x. X squared plus 1 equals 0. X equals 0. X squared plus 1 equals 0. X squared equals negative 1. X squared square root plus or minus negative 1. X equals plus or minus I. Yay! So x equals 0. Plus or minus I. Okay. Describe the in behavior. Okay, so it's an even x to the 6 and a positive 16. So it's going to behave like a parabola that's concave up. So as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. State all the possible rational roots. This is going to p over q. So p is 4, which means plus or minus 1, plus or minus 2, plus or minus 4. Then q is 16, so that's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 16. So p over q is going to be plus or minus 1, plus or minus 2, plus or minus 4. Oh gosh. Plus or minus 1/2. I'm going to use 2. 2 over 2 is 1. 4 over 2 is 2. Plus or minus 1/4. I'm now going to use 4 as a denominator. 1/2. 1. Plus or minus 1 over 16. 2/16 is 1/8. 1/8. And 1/4. I already have 1/4. Determine the possible positive roots. Okay, so we're going to use possible positive roots. Descartes' rule of signs. Look at the function. So positive 16 x to the 6th minus 64 x to the 4th minus x squared plus 4, which tells us that it's going to be 1, 2 sign changes. 2 sign changes, so 2 or 0. Negative roots are going to be, that's going to remain the same because that's even. That's going to remain the same because that's even. That's going to remain the same, plus 4. So it's going to be 2 or 0. Determine all the roots. We need 6 roots. Wow. Wow. Really? Okay. Let's go. Okay, so Let's go ahead and make our synthetic division. 16. That's x to the 6th. 0 for x to the 5th. Negative 64. 4x to the 4th. 0. Negative 1. 0, 4. Whoops. Okay, let's try 1. 16, 16, 16, 16. Nope. We need to somehow reduce that 64. It's too big. I'm going to try 2. 16. 16 times 2 is going to be 32. 32 times 2 is going to be 64. 0, 0, 0. Right? 0 and then 0 and then 0. Negative 1. Please work. Please. Negative 2. Please. Negative 2. Negative 4 and 0. Yes. Reduce it down to x to the, what was it? X to the, yeah, x to the 5th. Wow. Okay. Oh man. 16, 32, 0, 0, negative 1, negative 2. Let's go ahead and try. No, 1's not going to work. 2 again. 16. 16 times 3. No. 16 times 2. But it's not going to get rid of that 32. It's going to make it bigger. So therefore, I'm going to try a negative 2. So 16 and then negative 32. Ba-bam. Bam. 0. Add. 0. Multiply. 0. Add. And then negative 2. Multiply. Negative 2. Multiply. Bam. Oh, it worked. Reduce down to, so this was x to the 5th. This is x to the 4th. Okay. Whew. Keep on going. Okay. Let's try, what were the possible roots? Should we try 4? 16. No, it needs to make that 16 smaller. How about like something like negative 1/4 or 1/4? Let's try 1/4. Let's try negative 1/4. Bring down the 16. 16 times, that's 16 times negative 4 is going to be negative 4. I'm sorry. Times negative 1/4 is going to be. And then negative 4. And then 1. 1. And negative 1/4. Nope. I don't think that's gonna work. Yeah. Gosh, this reminds me of high school. I had to do one of these. I had to do these really long ones. And even on the test. Let's try like negative 1/2. 16. 8. Negative 8. Negative 8. Reduce that by 4. 4. Yes, I think it's going to work. And then negative 2, negative 2, and then 1, and then 0. Yay! Reduce down to x to the third. I have 1 positive, 1 negative, 1 negative. Let's try 1/2 again. Okay, 16. Half of 16 is 8. Ba-bam! 0 times 1/2 is 0, 4. And then 2, ba-bam! There we go. 16x to the second plus 4 equals 0. 16x squared equals negative 4. No. X squared equals negative 1 over 4. Square root x squared equals square root negative 1 over 4. It's going to be plus or minus. So x equals plus or minus I to the square root of 2. Whew. Yes. Okay. So what were all the roots? 2, negative 2, negative 1/2, 1/2, positive, plus or minus 1 over I over 2. So the roots are plus or minus 2, plus or minus 1/2, plus or minus I to the square root of 2. Now the factors are going to be x plus 2, x minus 2, x plus 1/2, x minus 1/2. And I'm just going to put 16 x to the second plus 4. I mean, 16x to this, if I divide that by 4, it's just 4x squared plus 1. So that still works too. Okay. Yeah. So I have to change these two. I mean, you could literally write it like that, but I just like this form better. And, or you can write 4x squared plus 1. Okay. Yes. Almost done, guys. Good job. 26. It says write the equation of the polynomial below. Okay. So let's go ahead and write the equation. And notice that it doesn't say standard form. Okay. So you can write it in factor form if you want. So the very first thing we're going to actually look at are the intercepts. Right here, and right here. And you can see that they just kind of pass through. They pass through, okay? Hold on. It needs to charge. Hold on. Okay. So right here, it looks like it's a negative 4. Right here, it looks like a negative 1. Or is it a negative 2? It's a negative 2. And right there, it looks like a 1. Okay. And it looks like they just pass through. So f of x equals x plus 4, and x plus 2 and x minus 1. And notice the end behavior. Look at the end behavior. Okay, is that going to have a positive coefficient or a negative coefficient? If you look, it's x to the third, because we have an x and an x and an x to the third. Okay, and so it's going to look like a linear function, so it's going to look like a business in the middle, but at the ends it's going to look like a positive slope. So that looks like a positive slope, so it's going to have a positive coefficient. So I can keep it the way it is because it could actually just have positive 1. Okay, now I can factor this out if I wanted to. Plus, what is that? 8. F of x equals x cubed plus 6x squared plus 8x minus x squared minus 6x minus 8. And then f of x equals x cubed plus 5x squared plus 2x minus 8. So I will accept this. This is the factored form. And this right here is the standard form. Okay, good job. Okay, so let's take a look. There's the x-intercept right here and right here. Okay, right here, 1, 2, 3, that looks like a -3. That's a 0 right there. And over there, 1, 2. Okay, so if I take a look at that, what does it happen at 0? It's squared. Yeah, it's a multiplicity of 2. Okay, it's a multiplicity of 2. And so, let's go ahead and look at the multiplicity of 2. Gives you extra points. Maybe we need to find a for these. Okay, so it's going to be f of x equals, we have x plus 3. That's going to be x squared because it's a multiplicity of 2, and an x minus 2. F of x equals, I forgot to find a, plus 3, x minus 2. It gives you an extra set of points, -2, -8. -8, a, -2 squared, -2 plus 3, -2 minus 2, right? -8 equals a times 4 times 1 times -4. -8 equals -16a. So a is 8 over 16. A is 1/2. Okay, that's going to be a positive. So it could be f of x equals 1/2 x squared, x plus 3, x minus 2. I can go ahead and factor that out. And so that ends up becoming x squared plus x minus 6, 1/2 x to the 4th plus x to the 3rd minus 6x squared. F of x. I will accept either one of those forms. That or that. Whatever you want. Okay. Let's go ahead and find. I forgot to find the a for these. I'm going to use that first. this one up here, f of x equals a. And so does it give me points? -1. So I'm going to use -1, -6. So -6 equals, what is that? -1 plus 4, -1 plus 2, -1 minus 1. So -6 equals a 3, 1, -1, -2, I'm sorry. So that's going to be -6 equals -6a. So a equals 1. Okay, so I didn't really need to find a. There we go. Okay. Good job, guys. Okay, now rough sketches. So with these, I think I am going to, what I'm going to do with these is it's going to be like probably matching. Okay. It's probably going to be matching. So there could be a couple of right answers for this. So, and it's a rough sketch. So it's a negative leading coefficient. So, and it's a 7th degree. So we know that the ends are going to look like that, just like a negative slope. And it has 3 x-intercepts, right? And 5 real roots. Okay. 5 real roots. And so 3 x-intercepts. And you can have it you can draw 1, you can draw 2, you can draw 3. You can draw 3 x-intercepts like that. Okay. And since there's 5 real roots, it means there's going to be a multiplicity. Okay. That means that 2 of them are going to have a multiplicity. So 3 x-intercepts, 1 x-intercept. You can do like 1 x-intercept with multiplicity of 2. And 1 x-intercept with a multiplicity of 2, and 1 x-intercept with a multiplicity of just 1. So that's 2 plus 2 plus 1, which is 5. So if it has a multiplicity of 2, then we know it's going to come down like this. It could bounce there. It could come like this. And then it could bounce again there. And then it could come like this. And then it could just go straight through here. And down to the negative. Or, okay, you can have 1 x-intercept with a multiplicity of 3 and 1 x-intercept with a multiplicity of 1 and 1 x-intercept with a multiplicity of 1. So this is going to be a bounce, and a pass through. And this is going to be a bend, and this is going to be a pass through, and this is going to be a pass through. So just put that, and I can put like, if I wanted to, 1, 2, 3. It doesn't matter how many. You can put them all on the positive side or the negative side. Doesn't matter. Okay. And then I can have this one bend. You can bend it like that and like this. And in behavior is going to look the same. And then we can have a pass through. And then we can have a pass through. Like that. There's so many different ways to do this. But you have to split the 5 up somehow. Okay? Now, 7th degree polynomial. 3-degree polynomial, 3 roots. So 3 real roots, 3 x-intercepts. That means all of the x-intercepts are just going to be pass-throughs. And once again, you can put those x-intercepts anywhere. I can put them all on the positive side. Doesn't really even matter. Positive leading coefficient. So it's a positive slope because it's a 3rd degree. So this side is going to go like this. And these are all just going to pass through. Like that. That looks like a positive slope on the ends. 4th degree. 4th degree. So it's going to be x to the 4th with a positive. So it's going to open up like that. Okay. That's what the end behavior is going to look like. It has 4 real roots, 2 x-intercepts. So 1 x-intercept could be a multiplicity of 2. And 1 x-intercept could be a multiplicity of 2. So both of them are going to bounce. Okay. So I can put 2 on the negative side. Once again, it does not matter. And remember, we have to start out here. And we're going to have to do one of these. And then it's going to bounce. And then just go to that side. Now, we can also have... I should have written that closer. We can also have 1 x-intercept with a multiplicity of 3. And that's going to bend. And 1 x-intercept with a multiplicity of 1. And that's just going to pass through. This time I'm going to make it all on the positive side. Like that. Four real roots. Okay. 2 here. Okay. Maybe it's going to come down like this and do a bend here. That could be the bend. And then that could just be the pass through. Okay. It says here 2 degree, 2nd degree, okay, negative. So it's going to be a parabola. It's going to have 2 real roots, 1 x-intercept. 1 x-intercept. It's going to bounce there. Ba-bam. Bounce. Did I finish all of them? Oh my gosh. I finished the entire study guide, guys. Good job.